What exactly is the GitHub Flow? Let's talk about that today. Welcome to this video on GitHub and DevOps. My name is Kevin Wiesel, and I'm the proprietor of Galaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. So far in this series, we have made a limited number of code changes. Of those changes, the only branch we've used is the default branch, which is main for this repository. This is not a great idea on the whole, for a couple of reasons. But to learn more, let's make our way into the classroom. Let's talk a bit about branches in source control systems. The metaphor of branches in source control brings to mind a tree with branches shooting out from a trunk. In fact, trunk was one name for this originating point, with branches forming off of the trunk and eventually merging back in. The strategy of how we work with branches has changed over time, but I'll lay things out from the perspective of Git, though it also applies to other source control systems as well. The makers of source control systems start with one key assumption. There are typically multiple people working on a project at one time. This assumption may not always be correct, but it's a pretty good one. For the sake of this video, I'm going to provide options that work better with single user and options that work better with multi-user scenarios respectively. When it comes to single user scenarios, the easiest approach is to use a single branch. The idea here is that we have our one branch and that's all we need. We commit directly to this one branch and do all of our work off of it. I'll generally go this route when I'm working on my own presentations, as I'm the only one doing any of the work, and I don't really benefit from having a more comprehensive workflow. But as soon as we have multiple people working on a project, I recommend switching to a different style of branching, such as feature branching. The idea here is that we have our primary branch, which will act as what we ship out to production. When we want to make a change to this code, each developer creates a separate branch. That way, if I pick up the task to reticulate splines and a coworker picks up the task to manifest reality, we won't step on each other's toes. I can make whatever changes I need to make to the code, and if I break something right before going home, it's no big deal. I can fix it in the morning. By contrast, if I broke something while checking into the primary branch, that would be a big deal, blocking other developers and maybe even preventing code from going out overnight. Working in separate branches decouples developers and the work that they do from each other as long as possible. At some point, of course, we have two options. Either we bring our code back together in the primary branch, or we abandon the branch forever. You could probably come up with some clever third option, but these are the two big ones. Let's suppose I finish my work with reticulating splines before my coworker finishes his work on manifesting reality. In that case, I can merge my changes into the master branch. Those changes are in the master branch, but they aren't in my coworker's branch. Instead, my coworker needs to pull those changes from master into his branch. That way, if we have merge conflicts, my coworker can sort those out before merging his code in and breaking the primary branch. A merge conflict, by the way, is a scenario in which two people have edited the same file in a way that our source control system cannot itself reconcile the issue. Source control systems don't play favorites. If you and I modify the same line of code, the system won't decide which is the correct line and which is the incorrect line. All it can do is complain that there's a discrepancy and leave it to us to sort things out. Fixing merge conflicts can be annoying sometimes, and that's where it's a good idea to minimize the likelihood of a merge conflict. The ways we can do that are as follows. First, coordinate with other developers who have access to the same codebase. If I'm working on a story to modify some database driver, I want to make sure that there aren't other developers actively working on that same code. If two devs don't touch the same code, it's way harder to have a merge conflict. Communication is a key here. Second, merge frequently and merge small change sets. The less time you have changes outside the primary branch, the less time there is for someone to write code that interferes with what you're doing. Third, pull the latest from your primary branch before creating a feature branch. That way, you've got the changes other people have made prior to you starting your task. Fourth, if you do have code checked out for a significant period of time, occasionally merge changes from the primary branch into your feature branch. That won't prevent merge conflict, but it will make them happen inside your own branch where you can fix them without needing to go through any real sort of mess. Fifth, try not to modify the same code in multiple feature branches. This is where I would make the argument that if you're editing the same files for 2 or 3 issues, it may be better to package those up as one feature branch and deploy them as a single unit. Alternatively, if you do need to keep those issues and code changes separated, only do one at a time, waiting until one change is fully deployed before moving on to the next. From there, it's easy to get to the idea of environmental branching. Environmental branching is a lot like feature branching, just with one added complexity. We have multiple environments. In this example, I created a new branch to work on reticulating splines. My colleague may also be working on manifesting reality, though I left that off the image to minimize complexity. Just as before, my branch comes off of master, as that's where my production codebase will live. I work on the feature branch until I'm satisfied with it, and then I can perform a pull request to a development branch. Then our automated systems could deploy that code to development servers, and we can repeat this process for however many environments we have. QA environment, staging, pre-production, whatever. Importantly, we create a new pull request for each of these environments, and then a different pull request for production. You might be wondering why we do that, and why we don't just merge dev into QA into staging, and so on, up into production. The reason for this is that we don't know what kind of detritus is floating around in the dev branch. My assumption is that, as I'm working to get my code out into prod, there are other people working at the same time, and even though I'm ready for my code to move, they may not be ready. Therefore, if we move dev into QA, we are moving all of the code changes, including the ones that nobody has verified as being ready. That's a no-go for me, and so instead we merge in the minimum necessary change. That is, the changes in my branch versus the current production, and we go from there. In order to support environmental branching, we need one more step to happen on occasion, and that is cleaning up those lower environment branches. We will inevitably have some releases which make it into the dev branch, but never go beyond there. Instead of having them hang out there forever, we occasionally say that we're going to force dev to look like the master branch, eliminating all of those partially completed or abandoned code changes. You may do this once every 3, 6, 12 months, whatever, but it's important to keep this on the calendar and do it periodically, as that will prevent errors popping up in lower environments brought about by abandoned code changes. Now that we've talked about branching, let's cover the rest of the flow. I've mentioned pull requests a couple of times already. A pull request is how we get code from one branch into another branch. There are 3 phases to our commit operations. The first phase is to commit, that is, to save a change locally in our source control system. Once you've committed a change, you have a record of the changes and can preserve that record for posterity. But that record is just on your local machine because Git is a distributed source control system. You can commit changes while being offline, but that's not the final step, not by a long shot. The second step is to push the change. Our local repository also ties to a repository in GitHub. In Git parlance, our local repository is our origin, and we have a GitHub repo as the remote. When we push a change, we push it from a given branch in the origin to a branch of the same name in the remote. In other words, if I have a feature branch called Reticulate Splines locally, then it's going to go into the Reticulate Splines branch in GitHub when I push. This ties us to the third step, creating a pull request. A pull request is how we indicate our desire to copy the state of a branch into a different branch. Note the difference in naming. When we push our code, we have the ability to force that move. By contrast, the assumption with moving to new branches is that we don't have the ability to force a move. Instead, we ask the owner of that branch to pull in our changes. In my case, I'm the owner, of course, but the idea of asking for a change to move to some other branch still applies. All of this context gives us an idea of how branching works in GitHub. Let's go to the demo and see how the pieces fit together. In exercise 3, we are going to make a simple change to our code. The code change isn't the important part of this task, however. The important part is that we will follow the GitHub Flow to do this. We'll create a GitHub issue, create a new branch, make any modifications we need to make, commit the changes locally, push the changes, and create a pull request into the main branch, deleting the feature branch after completion. That's a lot to do, so let's get to it. Our task, if we're bad enough dudes, is to modify the codebase and set the maximum message length from 200 characters to 250 characters. The first step is to create an issue, so let's switch to the Issues tab. On there, I'll select the New Issue button in order to bring up the New Issues page. Here, I'll quickly create an issue, indicating that we need messages with lengths of up to 250 characters. In a real-world issue, this is where we'd assign a person, slot it on the board, perform research, and so on. I'll do a very limited version of this. Let's first submit the new issue. Then I'll navigate to the Projects page and select the DevOps Kanban. I see that Jimmy the intern hasn't been doing much here, so I'll yell at that slacker the next time I see him. Regardless, I want to note that my new issue is not on here. A particular board does not necessarily get every new issue for some repository, but I can add the new issue to the backlog by selecting the Add Item link for the backlog. Then, if I enter a £, I can get a listing of my repositories. I'll select my repo, and then we can see the new issue, so let's add that to the board. Now I can talk through this with the dev team, give them time to research exactly what they need to do, size out the issue, and assign it to whomever. Those are all important process things that I'm simply going to skip over because it's just me doing the work here, so let's just move that into a ready state. This would signify that the task has everything we need to start work on it, and that's a true statement, so let's get started. I'm going to switch back to the repository and the code tab. In here, I have a drop-down showing the main branch. That's the only branch available right now, as I can see given the one branch label right next to it. Let me select that label. In here, I can create a new branch. I'll call it the issue number, followed by extend length. What we call the feature branch doesn't actually matter, as long as it's a unique label, that is. Often, you'll see people start a branch name with the ticket or issue number, but there's no requirement to do so. It does make things easier to look at in a large and busy corporate environment, though, so I would recommend following some pattern like this. I'll select Create New Branch to make that new branch available. Now let's do something with it. In GitHub Desktop, I'm in the code repo, and we can see that my current branch is main. I'll first fetch origin just to make sure I pick up any new branches or code changes in the remote repo, making them available to my local repo. After that, I'll select the current branch dropdown. We can see that my branch is in the Other Branches section, so let's switch over to that. As we can see, I'm now using this feature branch. My code change is fairly minimal. It turns out that in order to make this change, we simply need to go into the directory application/source/razor pages test sample/data and open up message.cs. On line 12, the string length for this text field is 200 characters. Let's change that to 250, making sure to change the error message as well to match. I'll save this change and get ready to commit it. By the way, you can do all of this source control work from within Visual Studio Code using the source control panel. This will let you commit changes to a branch, work with branches, push things remotely, and more. There's a lot going for this interface, but I will admit that I'm a little partial to GitHub Desktop, so I will switch back to that and keep using it. Just realize that this is my personal preference rather than some indictment of any other tool. Back in GitHub Desktop, I can see my changes. In the commit message, I'll type in fixes, pound, and then enter the issue number. If you use a phrase like fixes or resolves before an issue number, this will auto-close the issue once you merge the changes to the main branch. Let's select the button to commit this change. As I mentioned, committing the change is a local operation. It's in my local Git repo, but it's not in GitHub yet. Also, one nice thing that I like about GitHub Desktop is that it provides you an undo button at the bottom, just in case you goofed something up along the way before pushing those changes remotely. That's a nice bit of functionality, and it does keep you from having to perform a git reset in the command line. Now let's go to the next step in the process, pushing the change to GitHub. Pushing my committed changes to the remote repository is simple. In this case, I select the Push Origin button, and that will bundle up all of my changes. If I had several commits, it would send all of those as a single batch. Now I want to perform the final step and create a pull request to the main branch. Let's select the dropdown next to Preview Pull Request and choose Create Pull Request. After selecting the button, it creates a new pull request for me. This pull request screen looks a lot like an issue, but with a few modifications. First, we have the two branches up at the top of the screen. The branch on the right is our feature branch, and the branch on the left is the one we're merging into. In this case, I want to make absolutely sure that I'm merging into the main branch of my repository rather than the Microsoft repo. I'll double check that because this is a forked repo and it's easy to mess up and try to merge to the originating repo rather than your fork. Next, I have the title of my pull request. Because I had only one commit, the title of the pull request is the same as my commit. If you have multiple commits, there won't be a default title. Still, you can put whatever you'd like in the title and the description. Different projects may have special requirements regarding what information you should provide in here, so make sure you follow those instructions. Once I've completed all of that, I can add reviewers to the pull request if I so choose. I'll select myself as the assignee and then create the pull request. At this point, GitHub checks to see if we can merge our changes. One of the things it can do is run a CodeQL analysis to see if there are any vulnerabilities in the code. We'll get to that in a future video. We can also run unit tests, integration tests, and whatever other automated testing we'd like to perform to make sure that the pull request meets our code quality expectations. This may take a little bit of time to wrap up, so I'm going to wait until everything is in place. Good, now we're ready to go. All of our checks have passed and there are no conflicts with the base branch, so let's merge the pull request. Then I'll select the Confirm Merge button and we're good to go. The last thing I want to do is delete the branch now that I no longer need it. If I navigate to the Issues tab, we can see that GitHub has closed the issue. If we navigate to the Code tab, my change is in place and we're down to one branch. In GitHub Desktop, I can prepare for my next task by switching back to the main branch. We can see that there are a couple changes to fetch, so let's get those. After that, I'm going to select the current branch again and right-click on the feature branch and select Delete. I'll choose the Delete button and that branch is gone locally as well. And that, everybody, is the GitHub Flow. Following this basic set of actions will get you a long way, both in the open source world and in corporate environments. To summarize the GitHub Flow, here's the process. First, we create an issue. Then, we create a branch. Locally, we check out the branch and make our changes. We commit to the local repo, push those changes into the remote repo, and finally, we use pull requests to move between branches. Once we've merged everything into the primary branch and we're done, close the issue or issues associated with this feature request, and then delete the branch. This helps keep your repositories functional and clean, something that is critical once you start working on larger teams and larger projects. In the next video, we will go back to GitHub Actions and talk a bit about infrastructure as code. We'll have links and show notes in the description below. And until we see each other in the next video, take care.